Hello and welcome to episode 31, how to make a GTA 5-star game in Unity3d. Today we're going to be doing, continuing with the day-night cycle. We're going to be having it so the coordinates and day of year actually do things. So I'm just going to play around with the year, set it to say 20, let's go 2014, why not? Month, what is it? It's the 11th. Let's go with today, which is the 18th of the 11th, 2014. Sweet. Right, so let's open up our Sky script and create a new method under update called void set up sun, I suppose. So we need to create three variables. First one is going to be the latitude in radians. So let's just go lat underscore rad equals mathf dot deg to rad, which of course is degrees to radians, times latitude, latitude decimal rather. And then we need to do cos and sin for the latitude as well. So float lat underscore cos equals mathf dot cos lat underscore rad, and then float lat underscore sin, just a sign for it, equals mathf dot sin lat underscore rad. Sweet. So now I set up some local times. So float d, I suppose, equals was it 367 how many days are in here plus 1 times what do I name it? Times day in year dot year minus 7 times open bracket cycle, no, not cycle, we're talking about day in year dot year times open bracket again day in year dot month minus 9 divided by 12, and then close the bracket, and then divided by 4 times 275 times day in year dot month divided by 9 plus day in year dot day minus 730,000. No, that's wrong. 73,530. And voila. So that's that variable done. That's a pain in the ass to do, but yeah. I'll go through what all these are later. Just type them out first. And then another float. Float ECL equals 23.4393f. The f converts to a float minus. I'm going to put this method in the description or a link to it somewhere at least, because I understand this is going to be annoying to do. Minus 3 point, think of this as a standard form. 3.563 times 10 to the minus 7, and then times d. So, yeah. And then we need the radian, sin and cos for this, so ECL underscore rad equals mathf dot deg to rad times ECL, or ELC rather, float ELC underscore sin equals mathf dot sin ELC underscore rad, and then float ELC underscore cos equals mathf dot cos ELC underscore rad. Sweet. Right, I've typed it all out pre-hand, and this is going to be a long bit to do, so hold on just a second. Okay, so here it is. Here's the code that this will be in the description, don't worry. I know this is horrible to look at and everything. It's all mathsy. So these are local properties essentially, and it assigns all the variables in here. We have the sun theta and the sun phi, which act as the positioning of the sun. So now we're going to get to actually applying that to the sun, this little thing up here. So we have one last thing to do. We need to create a not variable, a method that returns vector3. So vector3, and we need to go orbital to local, and then we need to have pass through two floats, which will be theta and phi, which are of course the locations for each of the suns. So now we need a sin for each and cos for each. So float sin underscore theta and float equals math f dot sin theta. So of course this just makes it into a sin value, and then float cos underscore theta, which gives it a cos value, cos theta did d, there we go, and then float sin underscore phi equals math f dot sin, and then phi, not iPhone, that intelligence, and then float cos underscore phi equals math f dot cos phi. Sweet. So now, we need to create a new vector3. So vector3, let's go temp equals new vector3, and then oh god, in the x we need to go sin theta times cos phi. For the y is cos theta, and for the z is sin theta times sin phi, sin underscore phi, and then just simply return temp, which will return the vector3 called temp. So and then under where we finish the squiggly brackets for the local property thing, we need to first of all get rid of, in update where we have sun.transform.position equals that, get rid of that, but keep the lookat. So we need to go sun.transform.position equals orbital, oh not orbital, orbit to local. Oh, I did orbit, that's not a word. Orbit to local. And then we need to simply pass through sun theta and sun phi, which are in there, as you can see them. So if we go, so if we, it's odd. Oh, oops, I'm an idiot. We need to call setup sun in the update function. So above where we have sun.transform.position, sun.transform.lookat, just call the setup sun method. There we go. That would be why. So that's very cool. Hmm. Oh yeah. Oops. We need to go sun.transform.position equals orbital to local times. You simply have to times orbit to local times sky radius. That's it. So now when we save it and compile it and all that good stuff, we're going to see that the sun is in the correct position, and then as the time goes by, it will set, of course, as it should, with setting in the east and all that good stuff. So yeah, which is always good. And then, so obviously, if we change the coordinates, then it will update. And if we change the longitude, that works. And then obviously if the year changes it as well, strangely. And then of course we have the month, which of course would change it. So let me set it to midday. And sums up there, and I have it set to I set to the 21st of June rather, which is of course summer solstice. So and then we move the day around and like that. Remove the you're gonna see how the sun updates and all that, which is awesome. So it works perfectly fine. And then yeah, the sun over there. How long have we been going? 10 minutes, right? So what you're gonna find is a bit weird with the sky interpolations. So what we're gonna do is we're going to check whether I think it was, hold on, let me see. Yeah, okay. Hold on. Right, so I worked it out. So instead of having it so when it gets to a certain time it just lerps, we're doing it so depending on the angle, that's when it lerps. So as you can see. So what we've done is we've changed if the hour of day is greater than blah blah blah. I want to go if sun.transform to Euler angles.x is it's greater than -4 and if it's less than 8, we want to go lerp time equals mathf.abs, which means it will make, if we get any negative values, it will convert to positive. Sun.transform to Euler angles.x -8, and then close brackets divided by 8. So I'm just gonna set the day length, blah, 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 and then we play, and the day shall go by. There we go. Sun sets, as does the sky, which is awesome. So, and then it rises. Sweet. So yeah, that is that. I think that's the day-night cycle done, to be honest. So I don't know what I'm going to do next week. But yeah, thank you very much for watching, and I will see you in the next one. Bye-bye.